A very warm welcome to all of you, and thank you for joining us for the third edition of Smarter Conversations, a thought leadership series by AMNS India, proudly presented by Optigal. The Smarter Conversations webinar series has been thoughtfully curated to bring together insights that build and ideas that inspire, especially for professionals in engineering, design, and construction ecosystem. Today's session is titled Engineered for Excellence, Design and Innovation in PEBs, a theme that resonates deeply with the future of modern industrial construction and infrastructure. It is our privilege to host Mr. P. Surya Prakash, Managing Director of SatyaVani Projects and Consultants Private Limited, a leading consultancy firm he founded in 1994. With over 35 years of experience in civil and structural engineering, Mr. P. Surya Prakash has led numerous landmark projects across industrial buildings, warehouses, transmission towers, and logistics parks. So now let me hand it over to Mr. P. Surya Prakash to begin the conversation. Over to you, sir.
Good evening to all the respected delegates, participants, and students, some of the students. I'm very happy to be part of this optical smarter conversations, insights that build ideas that inspire. So today I'll be talking about engineered for excellence, design and innovation in PEBs. As introduced, I'm Managing Director of SatyaVani Projects and Consultants. So as per the request of the organizers, please write your questions in the program. They'll be taken towards the end of the session. If you have questions, please put it in the chat box. And today's topic, Engineered for Excellence, Design and Innovation in PEBs, is the topic of my presentation. And introduction to the topic is, India has opened up its economy during 90s, and there was a need for the construction industry to meet the demand of the growth in the open era. And pre-engineering is one of the revolution that started in mid-90s. And we all know pre-engineering basically means the pre-engineering of all the building components, like starting from structural components, roofing, cladding, and all other like joinery, windows, doors, everything which I'll be sharing today. And innovation has been happening since then, because we started implementing this pre-engineering concepts in all the building projects. And I'll share that experience for last 30 years, some of the projects that we have done and we are doing right now, and innovation that happened during the implementation of this project. And the major advantage of pre-engineering we have seen is in the quality, assured quality, faster timelines, and reduced cost even. Per square feet, if we see, it is very economical compared to previous fabricated structures, even steel structures. And safety is always very important in every project. So we are able to achieve better safety with these pre-engineering concepts, because all the components are predetermined and it is only the erection at the site. We have organized these buildings in industries, warehouses, logistics. The construction sector has been more organized, and every PEB company, they will have their authorized builders. So the SOPs are well defined, and the quality assurance program is also well defined. So we have seen in the last 30 years, this industry has grown from single vendor in the mid-90s to now almost every city we have these pre-engineered building vendors. So with this introduction, the overview of my today's presentation will be for PEB's horizontal construction. We all know it started with horizontal and then transformed into vertical construction. That is high-rise buildings also now we are able to do in pre-engineered building. Large span earlier, but large spans also being done with pre-engineered concepts, and skylight, lighting, and ventilation. So these are all the aspects I'll be covering today in my presentation. So coming to innovation, innovation is happening in aesthetics and roofing. We are seeing a lot of innovation. Today's presentation is also one of that part. I'll be covering roofing and cladding, what new advancements that we are seeing, and sustainability, which is a buzzword today in construction industry. We have to plan all sustainable aspects. I'll share some of the aspects of the sustainability and timely completion. That is, rapid construction is also a requirement, and I'll share some experiences using pre-engineering, how we can do rapid construction. And the flooring in all industrial projects, flooring is another important thing. And I'll share some experience of pre-engineered flooring even. And in design, we all know these being the lightweight structures, the major challenge is design for wind and design for stormwater disposal, quick disposal, and storage is one of the very important things nowadays we are seeing, whether it is Amazon or all the companies that are having logistics and supply chain management, last mile connectivity with these pre-engineered buildings only. The stores, large stores and all. So types of storage I'll be covering. HVAC, heating, ventilation, and air conditioning. So how we handle this in this large size of project, and the material handling, because most of the times we use this pre-engineered building in process industries where material handling is a very important thing, and also in logistic park we have the material handling, safety of the people, safety in maintenance also I'll be covering, and access and transportation in pre-engineered building, and automation in pre-engineered building. So these are all the aspects I'll be covering today. I know the time available and I have to cover many aspects, but I'll try to do as much justice as possible to all the topics. So horizontal PEB, we all know there are some buildings with single span and some buildings with multiple spans. And mezzanine floors will be required sometimes in buildings for various reasons. And the roofing, we have monoslope and a single ridge and multi-ridge. This kind of roofing slopes we have. So I'll be showing some of the pictures of the projects that we have done. So this is a first Kirby building that we have done from our office. Kirby Building Systems manufacturing plant, completely done in PEB. So it is a single ridge project with a future extension possibility. So this is the structure during erection. That time this building is about 360 meter long and 100 meters with multiple base and EOT cranes available. So these are the drawings with the EOT in all the base. And some of the defense projects also in Northeast we have done with the PEB sheet because of the snowfall and heavy rainfall in Northeastern region and associated with wind. We have designed these buildings, multiple buildings with pre-engineered building concepts, and particularly roof sheeting sloped with the single ridge type of roofing. So these are all some of the photographs of facilities that we have done. And I'll not go into individual details because I have to cover all the aspects of innovation, whatever I have briefed in the overview. So I'll try to cover them. And this is a air traffic control and crash bay in the Northeastern region. And this is that inside view during the process of that Kirby building. We can see how cleanly the pre-engineered building, very aesthetic and very economical in terms of sizes of members, and the structural steel consumption has drastically come down. And these are some of the process industries where we have used built-up sections and large industrial production areas in near Hyderabad, and tobacco manufacturing with the North Light roof, and edible oil industry refineries also. We have done 2-3 projects using the pre-engineered concepts. These are all some of the projects that we have done, even power plants. And this is auto cluster development, engineering industries. And this is a canopy you can see for an unloading bay in a logistic park actually. So canopy, we have this cantilever and you can see the downtake pipe going from the canopy to the wall inside. So this is the warehouse basically for ITC. And these are all State Warehousing Corporation with canopies. You can see multiple canopies with unloading bays. And next is the vertical PEB. Now this is happening for almost last 1.5 decades in India. Other countries, it is there earlier. So in vertical PEB, we have multi-story buildings. Now we are seeing in commercial applications also, apart from process building. Process buildings require vertical buildings, and some of the logistic park also we have done in vertical multi-story concept. So special fabrication requirements will be there for vertical. That's why specifically I'm covering vertical PEB. About 15 years back, if we see in India, we didn't have the capability for the vertical building PEB, like fabrication of heated welding and thickness going up to 40 mm, 50 mm even. So now in India, we have many PEB companies who can fabricate these higher thickness, and heated welding facilities are available. So India is prepared for vertical building. The only challenge is fire protection, for which also we have this intumescent paint. Earlier we didn't have. So in vertical buildings, fire protection is another thing. So this is the first tallest building in London. We all know Short Tower. So Short Tower is almost like 300-meter tall in pre-engineering concepts. So this I have come to know. And after that, we have visited some of the vertical buildings being constructed in 2012-13 time. So we have seen that a 1.5 million square feet high-rise building could be constructed in 9 months. 1.5 million square feet in vertical construction with, of course, central core in concrete actually. So this is the concept which can be implemented. And now in India, particularly in Hyderabad, we are seeing many commercial buildings in pre-engineered steel construction. So with composite deck, which is available. So I'll be covering those aspects also as we move forward. This is the building we did about 25 years back for ITC, 20-meter high, a pre-engineered concept building with all the built-up sections and cladding and roof sheeting, and with composite deck in between the floor. So this is the photograph of this completed building. And this is that, in fact, for ventilation, we have provided the staircase shafts, which will be working as hot air escape shaft, and also lighting shafts for the process area with the glazing. So this we have done, which has added to the aesthetics as well as this. And these are all moment resting frames. You can see there are no bracings provided in these buildings. So we have designed the moment resting frames. Only in gable end, we have provided some of the bracings which are required for the gable end. You know, where it requires a special design for the wind application. So this is the floor plan, 106-meter long and 66-meter wide and 20-meter tall building with all the fire escape staircases that are required from the safety requirement. So these are all the drawings for gable end, wind resting frame, and floor deck with the composite deck. And this is another oil refinery where also we have used high-rise vertical construction with pre-engineering concepts actually. So this is by now completed, and this is the first logistic building we have done for Gati Logistics in Hyderabad, 3 floors with composite deck and three-storied building with a pre-engineered building component. Next is the large span PEB. We all know large spans will be required in stadia and all, but also in some of the process industries, we use these large span buildings where we use built-up sections or spatial structures or latticed girders and box girders. So these are all the sections that we use in large span PEB. So this is for Sterlite, we did the 47-meter span with a box section fabricated and latticed purlin actually. So this is the drawing, and this is another project where without expansion joint, we have done about 220 meter by this. And here we have used the box section again, 50 meter span by 20 meter span requirement. And some of the stadia, indoor stadia and auditoriums we have done with spatial structures. Now coming to the lighting requirements in these pre-engineered buildings. Normally these large scale logistic parks, warehouses, we have done a single warehouse with a footprint of 7 lakh square feet. And we know the importance of lighting and ventilation. So we have to consider different types of lighting that are possible in this PEB. So in these large constructions, we go for strip lighting, window lighting, or north light in smaller buildings, and solar tube ceiling. So these are all the lighting methods that we adopt in this pre-engineered building. So this is one electrical assembly plant in Hyderabad. So we can see the skylight strip lighting. So it gives a very uniform lighting. This is during the day without any artificial light. In fact, we could have, and this is also controlled air. That is, ventilation is artificial ventilation. So this is about skylights and another rolling mill with the window type of skylight that we have provided. And this is automobile industry. You can see the lighting requirement. We have provided lowers with glass so that we'll have the lighting as well as ventilation and strip lighting. So this is for Mahindra in near Hyderabad. These are all the detailed drawings. And this is also engineered industry steel production unit. So here we have used again window and ridge ventilator. So ridge ventilation is very economical and natural draft ventilation that we can provide for the building, particularly in engineering industries. This is a north light roof. We have done with pre-engineering, and this is for again tobacco industry, where dry condition, humidity, very low humidity to be maintained. Because it's a tobacco industry, we maintain the artificial ventilation. Next comes my topic on aesthetics in PEB. So what are all the forms earlier we were constrained with only straight profiles. Means we used to use only plain sheets. Now we have multiple shapes of sheets possible. We are getting the readily formed sheets with all the curves possible required. So form facade elements we are having, and shell and dome elements we are getting, curved sheets we are getting, and we are using frames, these pre-engineered structural frames also in the facade elevations. So this is some of the concepts that we have developed for auditorium. One auditorium proposed with a dome, with the linear curved shapes and the double curved domes, and this is also domes we have developed for auditorium. And this is shell type structure for a convention center with pre-engineering sheets. And this is the multiple curved conical shells actually. So these are all the possible aesthetic things, and glazed dome and auditorium with the curved shapes. And this is of course in China I have seen. I like that concept structure being used for aesthetic purposes. The frames can be used for aesthetics. And this is the facade with all pre-engineered elements. Of course, it is ACP used here for the facade. Next is innovations in PEB. This is the central to my topic today. So roofing, earlier we used to have sheets punctured, and those galvalume sheets with the puncturing, and if we don't use these washers, neoprene washers, people used to use rubber washers, and there used to be a lot of corrosion and leakages through these punctured sheets. And even lighting, ventilation, north light roof also used to have a lot of problems with the leakages and gutters. So now we have this lot of developments in roofing with the standing seam, seamless roofing without puncture in the sheet, and also without lapping required. Single, almost like 50 meters, 60 meters side rolled roof sheeting we are using. Next is access doors, windows and lowers. I'll share those details, access doors, and canopies for loading and unloading bays, and precast concrete panels. Earlier, we used to have wall in masonry, and so the masonry walls used to take a lot of time. So now, thanks to precast concrete industry, we are getting the panels, and Acotec panels, also lightweight panel, we can use for the facade elements. And also above 3 meters, of course, we are going for this cladding, same metallic cladding. Next is flooring. We have a lot of innovation, seamless flooring. Earlier, I'll show these flooring details in this so-called vacuum dewatered flooring. We used to have a lot of joints, a lot of problems in execution. Now we have this fiber reinforcement, steel fiber reinforced flooring with a lot of advancements. Without joint, we can do even up to 5 lakh square feet of flooring. So that kind of, with no expansion joint, no construction joint required. So we have implemented these floors, seamless flooring, and gutters for rainwater, and flashing and purlins. Purlins, we know jet purlins, cold formed steel we are using for these purlins and girts in the cladding. So these are some of the buildings that we have developed with a lot of innovation in lighting, glazing, and this is that vertical building with shaft lighting as well as ventilation. You can see the windows here lowered window and roll-up window or swivel window and openable window. Total 6 layers of windows in 20 meters, which can be operated from the ground itself. So this kind of windows and glazing for lighting and ventilation, we have seen this lowered shaft at the top so that we can maintain the natural draft within the building. So this is the detailing of this pre-engineering we have done for this glazing and windows, a complete detailing. Now, today we have seen the video presentation before about what is optical. It's like optimum galvanized sheets. We have been using these galvanized color-coated sheets, but we were facing these problems of corrosion in these galvanized sheets even, though color-coated, because we cut the sheets during implementation for the site requirements and all. So even if we cut, it should not corrode. So how we can protect these galvanized sheets is what they have developed product. Really, it is very useful as I find in part of my innovation, that is zinc, aluminum and magnesium based alloy for a high performance and sustainability induced ArcelorMittal in Europe. 2013 they have developed, and now in India we have these optical sheets available, and they are available in different this one unicoat, multi-coat and corrosion free and corrosion 6 variants. So it has achieved all the required test results. So this is the composition of galvalume, and we can use these sheets against corrosion. And then you can see in the middle, earlier we used to use only zinc for the galvanizing. Now we have this zinc and aluminum, zinc-alum sheets. And the next development is we have this composite thing with zinc, aluminum and magnesium. So that is taking care of the corrosion aspect in these existing color-coated galvanized sheets. So you have these 4 variants in their product, like optical with ZM 120 and 55 micron nominal PU will give you 25 years of life warranty. So this is very, very required. In fact, I'm sure most of us engineers were being asked by end user, what is the life of my structure? So when we talk about life of structure, we have to talk about life of every component with the required maintenance and all. So depending on the life required for a temporary structure, we can go for optical core with the 15 micron nominal and ZM80, and optical pure 10 years life, and then prime 15 years life. Like that, depending on the actual life expected requirement, we can go for these products of optical. And these are all the applications as introduced earlier. They supply the coil to various PEB companies like Kirby, Pennar and other companies. So they produce the profiles for cladding, roofing profiles, sandwich panels and roofing. So we can use this tiled shaped sheet even. We have been using, actually it is available in all the towns nowadays. So this is the background of this because this is corrosion resistance optical. So with this, we can plan this roofing with the standing seam, solar panel clipping. We know Tata BlueScope has come up with a profile that you can clip the solar panels onto the roof. And we have this curved profile like a Proflex, and we have domes that can be done now with this sheeting and retractable roofs, which is a requirement nowadays in particularly sports. So these are all the standing seam roofs. You can see almost like 60 meters width length without any joint, and the standing seam, no puncturing of the sheet you can see here. And similarly, the domes we have done here for a courtyard skylight, and this is the detailing we have done. And this is the Proflex roofing we have done without purlins, without rafters. So the roof sheeting itself acts as a shell structure. So we can also get a better appearance aesthetically and design these structures without purlins. And next is the cladding. In cladding, as I mentioned before, we are using precast panels nowadays for up to 3 meters height, and lightweight panels also, depending on the application. And the metal cladding, of course, we have this zinc-alum and optical. And fascias, that is for the gutter and elevation requirements, fascias. And we are also using dry cladding, the stone dry cladding, wherever required. So this is the project where you can see we have used the glazing, we have used the cladding, metal cladding, and dry cladding, and a precast panels here. So this is the example of a cladding with multiple applications. Next is the sustainable PEB. PEB basically, though people talk about overall carbon emission or carbon footprint in steel, but if you see the apple-to-apple comparison for the same building, if we do in conventional concrete and masonry, definitely we have reduced consumption of material, reusable material used, and recycled content being more in this material. And we have the solar roofs where we can provide renewable energy and natural draft ventilation. We don't have to use any power with these ridge ventilation systems or radial exhaust that we provide in this building, and the natural light with this skylight and solar tubes. So the PEB will be more sustainable compared to other our concrete construction methods for this kind of large areas, like 5 lakh square feet, 6 lakh square feet of horizontal spread of the building. And now even in vertical buildings, we have seen in some of the projects, the steel is becoming more sustainable and economical in construction. So this is another sustainable project that we have done in Hyderabad for a clubhouse. You can see the form and shape of this building with the complete steel structure fabric, and you can see the roofing with all the curves that are required for aesthetic reason. And we have not disturbed any natural boulders in this building construction. So this is a sustainable construction in pre-engineered building. You can see these concept views. We have numbered each boulder and we have enumerated the masses. And we stitched these boulders. The boulders itself will act as the foundation. So there is no need for large concrete footings and all. So this is the project we completed with all sustainable concepts. And the architect wanted the boulders to be seen from the flooring. So they have given a glass floor on the steel structure. And we have retained all the boulders in their natural state. This was the before commencement of the construction. We have utilized the boulders. So this is during construction. So we anchored to the rock and we have stitched the boulders and we made the boulders connected as the raft itself. This is the conceptual view. You have seen the real photograph after completion and it is completed. Next is the timely completion of the projects with PEB. I myself could do 2 projects. One within 60 days, one auditorium from groundbreaking to conducting the conference, and another 30 days we have done using PEB. So we can do complete pre-engineering, including flooring, toilets, everything in the project without any civil component except for the foundation. So rapid execution, and we had assured quality and ease in construction with PEB. And we can do total pre-engineering, completely knocked down condition. Nowadays, we are seeing the buildings, people are selling houses for 5 lakh rupees. So it is possible. I'll show some of the things we have done even 30 years back. So modular PEB is, we have seen in Mohali, 48 hours, they have completed a 10-storied building with this modular PEB concept actually. And this is the VVIP gallery in e-racing in Hyderabad. We have done about 2 years back in 30 days from the groundbreaking to occupying the gallery. So this is a steel structure completely designed, including the design time we completed in 30 days. And this is an auditorium we have done again in Hyderabad in 60 days. And we have used complete pre-engineering, including the flooring of the auditorium. Those days we have used Aerocon panels for the flooring with the steel structure, pre-engineered steel structure. This is an edible oil factory we have done again in 12 months time. And this is a aluminum ore factory and many other industries. We have done timely completion without any delays in the project. 9 months we have completed, 12 months we have completed. Whatever time given, it is easy to plan and execute, control the timelines with the production because it's a controlled production in pre-engineering. So these are all the projects that we have done within the time. Next most important for all our engineers is the design of pre-engineered building. So the major decision that we have to take is whether we go for hinged base or fixed base, and whether we go for moment resting frames or braced frames. So this is a very important decision we have to take considering the type of soil and spans required and functional requirements. Sometimes we will not be allowed to use bracings because of the movement of vehicles within the building and all. So we have to decide. And next is the composite deck in mezzanine floors and multi-story PEBs. We use this composite deck. And the lattice deck, that is further advancement in composite deck, where the reinforcement that we use in the concrete itself, we use it as a lattice for supporting the deck sheet. So we can increase the span capability of the deck sheet from 2 meters to 6 meters by using that. And the foundations and plinth and roof slope is another important thing. When we go for these lapped sheeting joints, we'll have to have 1:10 slope. And when we have standing seam, we can go up to 1:20. So we'll reduce the load of gable end height with this slope. Suppose we are having 100 meters width of the building with a ridge at middle 50 meter. That means 1:10 will make it 5 meters ridge height, and 1:20 will make it 2.5 meters ridge height. So we have to take a very calculated decision, and there is a cost difference between seamless roof, standing seam roof, and jointed roof. But we have to consider overall cost. So these are the braced frames, and this is the deck sheet, composite deck slab, which we, of course, it's not very new. We have been using last 25 years, but improvement in this is this lattice deck. Of late, we are using this lattice deck. The reinforcement that goes into the concrete above the deck sheet will be used as a supporting lattice for the deck sheet, so that the span of the deck sheet is increased. So at the design stage itself, we have to consider these aspects so that we fix the slab thickness and all. And this is the design canopy that we have done, lattice. Next is wind in PEB. It's a very primary load. We all know that pre-engineered buildings design is governed by wind, whether it is roofing, cladding, gable end, and we also have to decide about the moment resting frames or braced frame, depending on the wind effects on the structure. And storage in PEB. Most of the PEBs will be used for storage. We have rack-supported PEB structures. We have stack-supported silos and automatic stack recovery system, which is being widely used by Amazon now. So this is the storage warehouse that we have done, 5 lakh square feet. And this is the storage racks that we get. So the floor load sometimes can go up to 10 tons per square meter. So depending on the storage requirements. So we have to design the flooring for that kind of loading. And when we have designed one building as a stack supported building, of course, this is a normal seed storage building. So next is the flooring in PEB. Earlier we used to go for vacuum dewatered flooring. Now we don't require vacuum dewatering because we have these admixtures, super plasticizers. So we need not do vacuum dewatering. We used to do vacuum dewatering because we have to achieve the required hardness and wear resistant flooring. But now with the floor hardeners that are available in chemicals, we can do without vacuum dewatering, but we can use the power flow. And also next development is seamless flooring. We have done, as I mentioned, using this steel fiber reinforcement actually. Next is the pre-engineered flooring. As I said, we can use these precast panels. Now in warehouses, data centers, we are using this pre-engineered flooring widely. The steel flooring, because fast flooring is required in data centers. So this is about 25, 27 years back, we have done the flooring, vacuum dewatering with so much of detailing of the joints, whether it is construction joints, transverse joints, or expansion joint. So we developed this flooring details, but now it is much simpler with the seamless flooring. Next is the stormwater in PEBs. So we all know we have single large buildings of 5 lakh square feet, which is equivalent to 10 acres and odd. But how do we plan the water drainage? Using gutters, using downtakes, and floor drains. So we have these predetermined gutters also available, pre-designed. Next is the heating, ventilation, and air conditioning, roof monitors, radial exhaust, lowers, heating and cooling. We have done This is a project where we had done heating from minus 20 degrees to plus 20 degrees actually. This is the heating system. You can see the ducts that we have provided. And lowers we design in the building. Next is the material handling in PEB. EOTs and monorails, conveyors, pipe conveyors, and ASRS systems. So this is the EOT you can see in the same building, of course. And material handling in Amazon, we have designed using, and this is the ASRS system almost 30 years back we have done for ITC. Here we have supported the roof with stacks itself. And the challenge was because ASRS requires 5 mm tolerance in the verticality. So for wind design also in the coastal region near Kakinada, we had to design the stack supported system with the 5 mm sway maximum. So for that wind speed of 50 meters per second. So this is the drawings of those material handling systems, conveyor galleries, rack supported system, and this is a hanging conveyor on the floor. So we have designed this hanging conveyor. Finally, safety in PEB. We need cradle runways, roof guide shafts, and walk ladders, railings. All this we have to design in the planning stage itself. So these are the ladders that we have provided, access ladder, and the stairs, access and transportation, elevators, travelators, escalators, and roll-up doors, sliding doors, rapid sectional doors. These are all required in some of the logistic parks, boom barriers, and rapid bollards. So this is the staircase drawings and portable cabins that I was telling we have been using last 30 years. Next is automation, induction coil, rapid roll-up doors, rapid sectional doors, because when we have the controlled air particularly, the movement of forklifts or these material handling system will require rapid sectional doors, for which we need automation with induction coil in the flooring and motorized sliding doors. We have designed this motorized sliding door of 32 meters with a width of 3 meters because this is a controlled air. So this is a motorized door system. So that's all I wanted to cover today. And if you have any questions, I request the organizers to coordinate picking up the questions from the chat box.
Thank you, sir. I'll take some questions from the chat. So the first one is that are pre-engineered buildings which are using the greener concepts for steel material feasible?
Yeah, because steel is a reusable material and it is a recyclable material. So it is always more green using steel. And even I worked out the carbon footprint for the same building for concrete as well as steel. It works out to be similar actually in the carbon footprint.
So I'll take the next question. So it is, what is the suggestion regarding the maintenance requirements for high-rise steel buildings?
In fact, in high-rise steel buildings, one major thing is corrosion, as we all know. And for corrosion resistance, we do the factory painted structural elements, and there is no side thing. And another thing we are doing in high-rise steel buildings particularly is encasing with concrete. So that will protect the steel members from the corrosion, as well as we can design for earthquake resistance, particularly these composite columns and composite beams. So high-rise buildings will come with steel structure, which is faster in erection, and encased columns later for more robustness in the design. We all know steel buildings have less robustness and less fire rating, fire resistance. So we have to, for fire resistance, we have this intumescent paint. We can do encased columns.
Sir, the next question we have is that there are various types of deck sheets available. How can we choose the right one?
Yeah, depending on the span requirement, we have the catalogs for the deck sheets. Galvanized deck sheet is preferred always, and depending on the span capability and the thickness of the slab that we require loading, we decide the deck sheet profile. And where we need, we cannot have more rafters. We can go for this lattice deck as I have introduced today.
So, based on the time, I'll take last few questions. So, it's what are the approximate dimensions of central concrete core of vertical PEBs? What are the specific design requirements for the central core, and what is the grade of concrete?
So that's a good question actually. The concrete core dimension is not decided by the structural requirement. What we do is depending on the functional requirement, that is number of elevators, number of ducts required, and number of staircases. Normally, this core will go into the center, and in the central core, we decide the thickness of concrete and the number of cores depending on the overall floor plate and lateral load resistance required. And the grade of concrete normally will have minimum M40 grade, because for these core structures, either we use slip form, jump form, or moving form. So it requires quick attaining of the strength. That's why we go for minimum M40 grade concrete.
Yes, sir. So the last question I want to ask is, what are the limitations of PEBs?
Limitation of PEB is location of the project, particularly, and then, in fact, now we don't have limitation for PEB. Only when we use large span structures like 12 meters and all transportation, the access to the site will be a limitation actually. When we use 12-meter long sections, and for roll forming also, we need the site available space for roll forming and pulling the sheet when we have the large span large building. But otherwise, for medium and small buildings, there are no limitations for use of PEB. It can be used anywhere, anytime. And that is why now PEB is gaining more ground in the industry.
Sir, I'll take just one last question. So, is the color coating sheets referring to Optigal can be used in the vertical cladding?
Definitely. There is no limitation. Basically, Optical is an improvement of our conventional Galvalume sheet, because Galvalume has the exposed steel component. Once we make this alloy that is named as Optical now, it will be more corrosion resistant alloy. And as we have seen with the coating and all, the life is extended up to 25 years, even if we use cut and use sheets actually. So that is the advantage of this Optical now.
Yes, sir. So thank you, sir, for that insightful and thought-provoking session on design and innovation in PEBs. So your experience and perspectives have truly added immense value to our understanding of how excellence in engineering can transform the infrastructure outcomes. So to all our attendees, thank you for being part of today's conversation. We hope you found it as enriching and engaging as we did. So do tune for the next episode in the series, where we'll continue to explore more such impactful ideas and stories from the world of engineering, design, and construction. Until then, take care and stay inspired and keep building smarter.
Thank you.
Thank you, sir.
I thank ArcelorMittal and Nippon Steel for giving me this opportunity. And I thank Deepal for connecting me to them. And thank all the audience for patiently hearing for the last 1 hour and insightful questions that are raised. Thank you very much.
Thank you, sir. Thank you all.